the velocity of center of mass. If a system is in motion, its velocity may be traced by center of mass itself. Suppose masses m1, m2 are having velocity v1, v2, then velocity of Cm will be given by this formula. The total mass of the system is suppose capital M, then velocity of Cm will be such that when we multiply the two, we get the sum of the momentum of all the constituents of the system. It might be also written as MVCM, that is M1V1 plus M2V2. One more thing we have to remember, that for finding the position vector of Cm, we can use this formula. Position vector. Sometimes there are two objects, it's astronomical phenomenon. When there are two astronomical objects, big, huge objects, and under the effect of their mutual gravitational attraction, they move towards each other. We know that internal forces do not contribute to shifting of Cm. So, if internal forces, that is gravitational force, that prevails there and it causes the motion of these two objects towards each other, the Cm should not move. I'll use this formula. See, this one. Cm should not move. And the masses, just suppose, are having velocity because they are having attraction. Obviously, they'll be moving towards each other. So, if one velocity is taken positive, the other must be taken negative. That means M2V2, it's M1V1. You might say V1 upon V2 is minus sign simply indicates that both have moved towards each other. But here we would say if two masses approach each other, then their velocities will be in the inverse ratio of their masses. Remember, external forces will move center of mass. Internal forces are not responsible. They are not capable of moving the center of mass. For example, one projectile, say one bomb has been projected, and somewhere on the way it just explodes in various fragments. Fragments might move in different direction, but the Cm of the whole system will continue moving as it was moving before the explosion, because there was no external force. Then for acceleration, we are going to have the same formula. Acceleration of Cm, that is given as m1a1. If they are in different direction, they are in 2D plane, then obviously we have to use the vector also. Total mass of the system, just suppose capital M, then we can write this way also. Means F1, F2 are the forces acting on the constituents. Total mass multiplied by this ACM will be given by this. This could also be written as M1A1 plus M2A2. Now for this hollow half ring, half disc and triangular lamina, we have tried to show the position of center of mass. Here for half ring it is 2r by pi above this center of complete ring. Similarly, this is 4r upon 3 pi, the location of Cm above the center of the complete disc. Similarly, we are having a triangular lamina lamina stands for thin sheet, then if these are the coordinates of vertices of the triangular lamina, we can have the position or location of CM in terms of x and y. It's given over here.